All right, welcome. We are looking at ACT Worksheet 211, Absolute Value and Inequalities. First half is absolute value, second half is inequalities. What I find is students who have only gone up to GCSE math, they are not familiar with absolute value. Students who've gone past GCSE math tend to recognize it as modulus or magnitude, but those who have not gone that far or unfamiliar with it. Not to worry, it's a very straightforward concept. The way it's tested on the ACT is maybe 2 problems out of 60 at the most per test. And once you know what it means and just how to solve when you see it, then it's not too difficult. And then the second half of this video is more of a familiar concept, and that's inequalities. Anyway, let's start to talk about absolute value. So I had a student ask me, a really strong student, ask me, what are the lines? And I was like, do you mean the equation for a line? What do you mean? And he goes, no, the lines, they keep on coming up and I don't know what to do. What he meant was the lines for absolute value. So treat these absolute value lines like brackets, okay? So anything that's inside them, solve that first. So if you think of bid mass, anything inside the brackets you have to solve first. What absolute value means is it means distance from zero. Distance from zero is always positive. For example, here's 0, here's negative 16, here's positive 16. If I put brackets around 16 and negative 16, the absolute value brackets, the result of both of these is 16. Why? Because the brackets say, hey, whatever is inside this, we just want to know the distance that it is from 0. Well, negative 16 has a distance of 16 from 0, and positive 16 has a distance of 16 from 0. So if we're looking at this problem, the mistake a lot of people make is they take this minus 15 and they make it a positive 15. You don't want to do that yet. And the reason why you don't want to do that is because you need to solve what's in the brackets before you actually apply the absolute value. So instead of making that a positive 15, you do the math. So you do 8 minus 15 is negative 7. And now that you've done the math within the brackets, now you apply the absolute value, so the output would be 7. Okay. So let's look at a problem that I've created here. So we have the absolute value of 2x plus 8 equals 20. And we want to know what are the possible values for x. Well, let's think about this logically first. Okay. If we think about it, whatever's in the brackets has to either be 20 or negative 20. Okay. So if we think about how do we make this 20, well, we need to make x 6, right? If we make x 6, then 2 times 6 is 12 plus 8 is 20. So how do we make it negative 20? Well, if we want to make it negative 20, x would have to be negative 14. Negative 14 times 2 is negative 28 plus 8 gets us negative 20. Absolute value of negative 20 is 20. So x could equal 6 or negative 14. So the question is, how would we do this mathematically? And the way is right here. This is how you do it algebraically. It's very simple. You either say, hey, 2x plus 8 itself is going to be 20, or 2x plus 8 is going to be negative 20, meaning that the opposite of 2x plus 8 will get me 20. So that's how you write it out algebraically, and that can come in handy, and we'll see that on a problem later. But 2x equals 12, x equals 6, so that's one of our values, and another value, negative 2x minus 8 equals 28. So we know negative 2x equals 20, not 28. I was one step ahead. So negative 2x equals 28, meaning that x is going to equal negative 14. So that's how you do it. You either say, hey, the thing itself equals the answer, or the thing itself is opposite of the answer, so the opposite of the thing itself equals the answer. Okay. Picked out a few problems here. Feel free to pause the video and see if you can do 4. 4, it would come within like the first 30 problems. It's considered fairly easy if you understand how to read absolute value. Anyway, if you haven't paused the video, you do what's in the brackets first. So we have negative 54 plus 20 in absolute value brackets. That gets you negative 34. Well, the absolute value of negative 34 is 34. In fact, A is immediately gone because nothing in absolute value brackets, once you apply the absolute value, can be less than 0. Has to be 0 or positive. Okay. Here's a great problem. Again, feel free to pause the video and give it a shot. If not, just kind of ride along with me. So it says, which of the following expressions is equal to this? So first things first, this came on the last 20 problems. It's actually not that hard if you think to do one thing. Whenever they want you to match expressions, understand that if I put in inputs for A, B, and C, and I get an output, the same expression with the same inputs should yield the same output. Let me show you what I mean by this. So they say A, B, and C have to be real numbers. I'm just going to make up that A equals, let's say, 10, B equals 2, C equals 3. I just chose numbers that I thought would be easy to work with. You can play around with any numbers. So if we look at this, we have 10 minus 2 minus 3. We have the absolute value of positive 5, and the absolute value of positive 5 is 5. So with these inputs, we get an answer of 5. So let's play around with this. 10 plus 2 plus 3, absolute value is 15. A doesn't match. 10 plus 2 is 12, minus 3 is 9. Absolute value of 9 doesn't match. 10 minus 2 is 8, plus 3 is 11. Absolute value of 11 doesn't match. Negative 10 plus 2 plus 3, that gets us an absolute value of negative 5, which is 5. That matches. And then real quickly, just to check E, negative 10 minus 2 is negative 12, minus 3 is negative 15. Absolute value of negative 15 is 15. That doesn't match. Easiest way to do this problem is just to throw numbers and go. If you wanted to think about it conceptually, well, I'm actually not even going to bother with the conceptual part of this. All right, we'll explain it real quickly. So the numbers we picked, it's almost easier just to understand that, or I made B2. So if you were to think about this, on a number line, we have 10. We're 10 away from 0. But then subtracting 2 and 3 moves us to 5 away from 0. Well, if we go on the other end, if we're looking at D, we're an absolute value of 10 away from 0. But then adding 2 and 3 gets us an absolute value of 5 away from 0. So it's just flipping what side we're on. But again, that's so much easier to see with numbers. Okay. 21 is a really cool problem. Again, feel free to pause and try it out. I like these absolute value problems because they tend to involve just number theory and doing a little bit of thinking. If you haven't paused the video, last chance. We're going to keep on going. Okay. So it's asking us which of the following is true. And I find that you can think about it logically. And if you're stuck or you're not entirely sure, you can play around with numbers. You can plug in a negative number for x, I find is helpful. You can plug in 0, you can plug in a fraction, and you can plug in a positive number. If you do that, you've pretty much exhausted most possible outcomes on the number spectrum. So you can feel pretty comfortable with your answer. So let's think about this. Is x never 0? Well, no, it could be 0, because if we put in 0 minus 0, then we'd get out 0. And 0 is a real number. Also, if we put in a positive number like 2, 2 minus the absolute value of 2 is 2. So it would just be 2 minus 2, which would be 0, if you think about that. So that gets rid of never 0, always 0. So you may be thinking, well, it's always 0, because if I put in 0 for x, it works. I get 0. If I put in a positive number for x, it works. But if you were to put in negative 2, you'd have negative 2 minus the absolute value of negative 2, which is really negative 2 minus 2. That's going to get you negative 4. So it's not always 0. Always positive. Well, no, that's not necessarily true, because we figured out that a lot of times it's 0. Sometimes positive, never positive. Well, we figured out, so we're between sometimes positive and never positive. Well, what we realize is if we plug in 0, we're going to get out 0. If we plug in a positive number, we're going to get out 0. If we plug in a negative number, we're going to get out a negative. So we're never going to be positive. Hopefully that makes sense. And I can kind of quickly show that real fast. If you plug in a negative number, you get a negative. If I were to plug in a positive here, I'm going to get out, it's going to be 2 minus 2, which is going to be 0. Okay, hopefully that's helpful. Let's look at inequality problems. These should be a little bit more familiar from GCSE. First things first, on an inequality, if you divide by a negative, you have to make sure you flip the sign. That's very important. If you think about it, it makes sense. 10 is greater than 5. If I multiply these by negative 1, negative 10 is not greater than negative 5. But negative 10 is less than negative 5. What happens is that when you multiply by a negative, what you're doing is the greater number becomes further from 0, but it comes further from 0 in the negative direction. So this is actually negative 5 is actually closer to 0, so it's a greater number than negative 10. Anyway, if we have this situation, on a number line, it will look like this. You shade in the possible values, and if it's not equal to, then you keep the dots open. You close them if it's x is greater than or equal to 3, the equal to sign, or less than or equal to 13, that's when you close the dots. If we were to graph it, it would look like this. So if we have y is greater than or equal to 3x plus 2, we make the line 3x plus 2, and we shade up from the line. It's different than GCSE. You shade towards what you will take or what you want, rather than what you don't want. So you shade towards what is acceptable as an answer. So if we're looking at example 1, y is greater than 3x plus 2, it's a dotted line because we're not including the line, and we shade up. If y is less than 3x plus 2, we do the line again, but in this case, we fill in the line because we're including it, and we shade down because y is less. Okay, let's look at a few inequalities. This is a great problem, 26. It may be the hardest one on the packet. So it says the solution, and feel free to pause it and give it a try as well. But as always, we'll keep on rolling. The solution set for the inequality 2x minus a is less than or equal to 3. And x has to be within this range. What is the value of a? So there's a lot going on here. I find the easiest thing to do is to plug in possible values at the extremes. So we're going to do x equals 1. And we're going to try, and I'll do this in a different color, we're going to try x equals 4. And we're going to see if that can kind of narrow down our values from the answer choices. So this is where understanding how to do an absolute value, how to write it out, comes in handy. So if we make x equal 1, we have two possible things. We can say 2 times 1 minus a is less than or equal to 3. Or the other possibility, and I'll do it down here, is the opposite of 2 times 1. If you remember from earlier, the two possible solutions are either the thing itself is less than or equal to 3, or the opposite of the thing itself is less than or equal to 3. So if we do this one, we have 2 minus a is less than or equal to 3. So what we get is I'll move up here, we get negative a is less than or equal to -1. And then divide by a negative, the sign has to flip. So a has to be greater than or equal to 1. So that's what we know so far. If I make a number line, here's 0, here's 1. And we know that we are going to have to shade in this direction. And let me real quickly check the math here. We plugged in 1 for x, 2 minus a, subtracted. Oh, that's not a negative. Ooh, glad I checked. I knew that didn't feel right. You're probably shouting at the screen. So if we look at this again, we have negative a is less than or equal to 3 minus 2 is 1, not -1. So we actually don't flip. We will flip the sign, but what it will look like is it will look like a is greater than or equal to -1. So really, we're shading up from -1. And we're going to fill it in. Okay, so we'll shade up, but let's kind of see the rest of this. So down here, and maybe what I'll do is I will move this over. I can try to do it in this space because it's important we have this space in a moment. So -2 plus a is less than or equal to 3. That means that a is less than or equal to 5. So right now, we know that a has to be shaded within this range between -1 and 5. What does that get rid of? That only gets rid of 11. So, all right, thanks a lot. That was helpful. But we shouldn't give up yet. Let's see what happens here. So if we plug in 4, what we'll have is we'll have 2 times 4 minus a is less than or equal to 3. Or, let me see if I have space here. I'll do it down here. The opposite of 2 times 4 minus a is less than or equal to 3. So if we do it here, we have 8 minus a is less than or equal to 3. That means that negative a is less than or equal to -5. So we get that a is going to have to be greater than or equal to 5. That's really interesting. So now we're told here that a has to be less than or equal to 5, and here we're told a has to be greater than or equal to 5. We don't have to do any more work. If that's the case, the only number a can be is 5. So we could solve this academically just to see what happens, but we've already got our restrictions. It has to be 5, because in order to follow through on these two possibilities, a can only be 5 to make it work. But anyway, if we did this, we'd get -8 plus a is less than or equal to 3. We'd get a is less than or equal to 11, and 5, again, is within that range. So we know we're still okay. All right, so anyway, that's that problem. Let's take a look at 29. Which of the following statements gives the real number values for x squared is greater than x? So they're kind of testing you on number properties a little bit here with this inequality. I would just go right to the answer choices and just play around with it. This problem is in the last 20 on a test. You have every reason to get this one right. So if we plug in a half, what we're going to get is we're going to get a half squared is 1/4. I'm just trying out a. And that's going to be less than a half. So we're going to know when is x squared less than x. Well, I think we already figured it out. It's got to be a. If we do the negative version, so if we tried -1/2, what would happen is -1/2 squared is going to get us 1/4, and 1/4 is not less than -1/2. So we know that if it's a negative number and we square it, then the square is going to be greater than if it remains negative. So really, x can't be a negative number for this to work. If x is a positive number greater than 1, well, the minute you square a positive number, if we made x 2, the square of a positive number greater than 1 is going to be greater than the number itself. So really, it only works if we have a fraction, because when you have a fraction that's less than between 0 and 1, if you square the top and the bottom, what happens is the bottom becomes greater faster than the top does. So in that case, the number becomes smaller, right? Like if I had 2/3 and I square that, squaring 3 is going to become much bigger than squaring 2. So the separation between these two becomes greater rather than separation of 1, separation of 5, and this becomes a much smaller number. So anyway, 29 is A. Okay, last problem, and feel free to pause the video. This one, I find it's super easy as long as you're willing to plug in numbers. You can try to do number theory and think about it, that's fine as well, but we're gonna do this super fast by plugging in numbers. If A is an integer less than 1, -1, okay, so we'll call A -2. Which of the following orders the expressions from least to greatest? Okay, so the absolute value of -2 becomes 2. The absolute value, or sorry, not the absolute value, -2 squared, opposite of, that's going to yield 4, -4. So this one's -4. You have to make sure that you put in the -2 in brackets and then apply that negative at the end. So whenever you're plugging in for a variable, you always plug in with brackets. That's a way you could possibly miss this problem. Anyway, this other one, if we have -1 over A, -2, that's going to get us +1/2. So we need to put these in order. So if we put them in order from least to greatest, this one's the least, so gets rid of A, B, and C. The middle one is going to be this one, so we know that it's E, and the greatest one is going to be the absolute value of A. So our answer to that one is E. Okay, and then I guess the biggest takeaway, just to emphasize it again, is that if you're inputting for a variable, make that input for A in brackets and leave this negative outside. It's a very common mistake I see made. Okay, hopefully this makes you feel much more familiar and comfortable with absolute value. Good luck on the packet. And as always, feel free to return for any other videos with any of the other packets.